Hello and welcome. Did you hear the joke about the roof? No? Oh, never mind. It'd be over your head anyway. But something that's not going to be over your head after this video is L'Hopital's rule. So let's get started. If we revisit limits just for a moment, you might recall that the limit as x approaches 1 of x squared minus 1 all over x minus 1, the way we would approach that was we would factor the x squared minus 1 on the top and cancel off the factor of x minus 1. That was the factor that was making the bottom 0. So this is how we would do this kind of a problem before. So factor the top, cancel off that factor that's making both the top and the bottom 0, and then you could plug in the limit, plug in the x value that you're approaching, and you would get 2. So in this kind of a limit, one of the things that was a clue that we should do this kind of thing, try to factor the top, was that both the top and the bottom of the fraction were approaching 0. These kind of limits that are 0 over 0 type limits are said to be indeterminate. Let me make that a little better. And we mentioned that way back when we were talking about limits at the beginning. So as it mentions previously, we would try to cancel a factor, then take the limit again. But let's turn to another powerful tool that can help us evaluate 0 over 0 type limits, these indeterminate limits. And that's called L'Hopital's rule. So L'Hopital's rule says this. Suppose that the top and the bottom are both 0 when you plug in the x value that you're approaching. So that's f of a equals f of g, f of a equals g of a equals 0. And that both f and g, the top and the bottom functions, are differentiable on an open interval I containing a. So differentiable as long as you're close to a. And that the derivative of the bottom function is not equal to 0 on that interval if x is not equal to a. With all these conditions in place, it turns out that the limit as x approaches a of f of x over g of x, that's our original limit, is equal to this new limit as x approaches a of f prime of x over g prime of x. So it's amazing that all you have to do if you get a 0 over 0 type limit with all these conditions met is take the derivative of the top function and take the derivative of the bottom function, and now that new limit that you have is equal to the limit that you started with. So it's a pretty amazing rule. Let's use it in example 1, where we're going to evaluate that limit as x approaches 1 of x squared minus 1 over x minus 1. And rather than factor, we're going to use this L'Hopital rule. And I think the first thing that you always want to do is identify that you can use L'Hopital's rule. And the main thing is that it has to be a 0 over 0 type limit. So this is going to be, we'll write out this is a 0 over 0 type limit. The way you can figure that out is just plug in the x value in the top and the bottom for the most part. And you get 0 on the top, 0 on the bottom. So then we can take a step of L'Hopital's rule, using L'Hopital's rule. Now I know it looks like hospital. I don't know what to say other than it's a French name that is, at least here in the US, is pronounced L'Hopital. I don't know if that's the way you pronounce it in France or French, but that's just typically how I've heard it said. So I'm passing that along to you guys, for better or for worse. Oh, I should mention that another way of writing it, so L'Hopital, another way of writing it is L apostrophe H O with a little hat, and then without the S, and then P-I-T-A-L. So I'm kind of wishing I had taken French in high school, but oh well. Okay, so L'Hopital says then that, or L'Hopital's rule, L'Hopital doesn't really say anything these days. L'Hopital says that you can take L'Hopital's rule says that you can take the derivative of the top, which would be 2x, take the derivative of the bottom, which would be 1, and now this new limit of 2x over 1 as x approaches 1 is going to be equal to the old limit. Now we can evaluate this new limit by plugging in x equals 1, and we get 2, which is exactly what we had before. We got 2 before by doing that other technique that we talked about. That's pretty cool. L'Hopital helps us out. One of the things you might wonder is, why didn't we ever do that to begin with? Why not just use L'Hopital? But, well, we didn't know about derivatives back when we first learned limits. We had to talk about limits first so that we could be able to define the derivative, and then we talked about the derivative shortcuts after that. So we couldn't start using those derivative shortcuts back when we were initially evaluating limits. But now that we have the derivative shortcuts, L'Hopital's rule is a very powerful way of evaluating these indeterminate limits. Let's do a couple more of these. So if we notice with this limit, if you plug in x equals 0 in the top, you get 0 minus sine 0, which is 0. And in the bottom, you get 0 cubed, which is 0. So we can use L'Hopital's rule. We'll just write from here to here. We're using L'Hopital's rule. I'll just abbreviate it with LOP. We take a LOP. So that'll be 1 minus cosine x on the top, and then 3x squared on the bottom. Something that sometimes confuses students is, aren't we just using like a quotient rule or something like that? Remember that the quotient rule is when you're taking the derivative of a fraction. Whereas here, we're not taking the derivative of a fraction. We're trying to evaluate the limit of this fraction. And we're just happening to use the derivatives separately of the top function and separately of the bottom function as part of L'Hopital's rule. So we're not taking the derivative of the whole fraction, we're just taking the derivatives of the parts, the top and the bottom. So I wanted to point that out, because it's not a super common mistake, but sometimes happens and you just want to be aware of it. All right, let's take a look at our new limit and see what type we have. If we plug in 0 into the top, we get 1 minus cosine 0, which is 1 minus 1, which is 0, over, and then plug in 0 in the bottom, and we get 0. So this is a 0 over 0 type limit. So what can we do? Use L'Hopital again. So this step is going to be another LOP. Nobody says LOP, only maybe other people say LOP, I don't know, but I just made that up. So you use L'Hopital's rule again. So the derivative of the top of 1 minus cosine x is going to be, well, the 1 will disappear because the derivative of a constant is 0. And then the derivative of cosine x is negative sine x. This extra negative will turn that into a positive sine x. And on the bottom, you'll get 6x. Let's check what we have again. If we plug in 0 on the top, we get 0. 0 on the bottom, we get 0. So yet again, we're going to use L'Hopital. So we have the limit as x approaches 0 of cosine x over 6. Now we'll check our new limit. If we plug in 0 into the top, we get 1. Immediately we know that we can't use L'Hopital after this, because you can only use it when you have 0 over 0, or as we'll say in the future, possibly infinity over infinity. That's another possible case of L'Hopital. But here, if we got a finite number 1, so a non-zero finite number, immediately you know can't use L'Hopital here. So, but that's okay, because we can just plug in 1 and we get cosine 0, which is 1 on the top. Sorry, plug in 0 and we get cosine 0, which is 1 on the top. We get 6 on the bottom. A cloud just passed over the sun. And that gives us 1 over 6. Let me actually write that out for you guys. Cosine 0 over 6, which is 1 over 6. let's do one more L'Hopital example for this video. Here, if we plug in x equals 0 into the top, we have 1 minus cosine 0, which is 1 minus 1, which is 0. X equals 0 into the bottom, we get 0. So we know we can use L'Hopital. So the derivative of 1 minus cosine x, oh, actually we did that before, that's sine x. Derivative of the bottom is 1 plus 2x. Now we're going to check, and we have, let's see what kind of limit this is. We have 0 on the top and 1 on the bottom. Can we use L'Hopital? Nope, because it's not 0 over 0. So we'll go ahead and plug in x equals 0. And we get 0 over 1, which is 0. When the 0 is over, it's 0. So the last note on this page is that L'Hopital's rule also applies to one-sided limits as well. So for example, if you were taking the limit as x approaches 0 from the right of sine x over x squared, that's a 0 over 0 type limit. And just the fact that it's coming from the right doesn't matter. We can use L'Hopital for that kind of situation as well, and also left-hand limits. So thank you for watching, and see you in the next video.